Good morning, everyone. I'm here to talk to you about robotics and machine learning in manufacturing. Now, before we talk about where we're going, I think it's important to set the stage and talk about where we've come from. And really, over the last 250 years, we've experienced 3 industrial revolutions. In the span of about a dozen generations, we've gone from a pastoral, agriculturally focused lifestyle to one dominated by machines and automation. The first industrial revolution saw the advent of what are called machine tools and the ability to start to mass produce certain types of goods. In fact, one of the goods that came out of that first industrial revolution is this, the humble screw. Now, you may be asking yourself why, in a talk about machine learning and robotics, I'm actually talking about screws, but this actually embodies an important theme that I'll be returning to throughout my talk. This screw and the ability to easily mass produce the standardized screw is what laid the foundation for the second industrial revolution, best embodied by the assembly line of Henry Ford, which in turn paved the way for the third industrial revolution that is celebrated in the very building that we find ourselves in today, the digital revolution, computers. And that's the theme that I'm going to be talking about throughout this, this presentation here, is the idea that standardization and usability lay the foundation for what comes next. And by the way, the United States has been central to all of these revolutions over the last dozen generations. And I know that there's a lot of hand-wringing out there about how we don't make anything in this country anymore, and everything's been outsourced overseas. But the truth of the matter is, the United States today is still, in fact, a manufacturing powerhouse. We make over $2.2 trillion worth of goods on an annual basis, employing nearly 13 million people, scattered across over 300,000 factories. And the types of things that we're able to produce here are powered by technology. In fact, the United States invented the first robot. And around the same time that we were able to produce the first mass-producible robot, we were able to also start mass-producing computers. But these are 2 technologies that have had very, very divergent adoption curves. The very first robot was actually deployed into a General Motors factory in Trenton, New Jersey in 1961. Again, roughly around the same time that we started to mass produce computers. Today, there are hundreds of computers in this very room, in this building. Yet there is precisely one robot in this building. And that's a robot that our company brought here as a demo. So where are all the robots? How come there are only 40,000 robots sold per year in the United States and 400,000 globally, a number that is less than the number of iPhones that Apple sells in a day? To really understand why there's been such a divergence between these 2 technologies, we're going to take a little bit of a trip back through time. We're going to go back to the 1980s. Because it's the 1980s that really saw the inflection point for computers and the beginning of that divergence. I'm going to talk about for a moment how robots are programmed in the 1980s and how they're programmed today. They're actually programmed through a device called a teach pendant. And that teach pendant looks like this. It's got dozens of buttons. It's got a small LCD screen. Kind of looks like an oversized graphing calculator from the 1980s. And using that teach pendant, you're programming in a language that is unique to that vendor. So if you're programming on a Yaskawa robot, you're programming in a language called Inform. If you're programming on a FANUC robot, it's a language called Carol. ABB uses Rapid. Kawasaki uses AS. I could sit here and I could rattle off dozens of these different languages. It's a highly fragmented landscape, and it's one that doesn't really pay attention to the importance of usability. In fact, the last leap forward in usability when it comes to robots actually happened in 2005, nearly 2 decades ago now, and that was from a company called Universal Robots. that makes the teach pendant that you see on the left there. And that was actually a great leap forward in robotics, and it demonstrated to the industry the importance of usability. So usability and standardization. Usability being something that the computer industry really realized helped drive massive growth and adoption. In the 1980s, at that inflection point, what happened? Well, there was the advent of spreadsheet software, first with VisiCalc, later with Excel. And that spreadsheet software was really the first example of a no-code programming interface for computers. It is an interface that enabled accountants and financial professionals to be able to leverage the tremendous power of computers without needing to write a single line of code. And that really helped drive that mass adoption by empowering them to do this type of complex computation, again, in a no-code environment. So that's where we've come from. Now let's talk about where we're going. Here at READY Robotics, perhaps unsurprisingly, given the theme of my talk, we're focused on two things. We're focused on standardization and usability. At READY Robotics, we make a suite of end-user-facing productivity apps that enable people in the manufacturing environment to very easily use robots from a variety of leading vendors and use it the exact same way. So using our platform, Forge OS, and the productivity apps that run on top of it, you can program Fanucs and Yaskawas and ABBs, Kawasaki's, all the exact same way. And this is something that is tremendously important to help move the industry forward, because there's actually a massive problem in manufacturing today, and that's what's called the manufacturing skills gap. There are over 800,000 unfilled jobs in manufacturing today, tasks that ultimately could be filled by robotic automation if it was easier to deploy them. And this is something, obviously, that we are very, very focused on, is the idea of making it easier for end users, making it easier, like this guy up on this slide here, who is a very intelligent guy, very hardworking, very mechanically adept, knows his way around these type of big, complicated machines. But what he doesn't know how to do is program. And so his ability to be effective in the industry is stymied by unnecessary complexity and fragmentation. So everyone is talking about the coming fourth industrial revolution. And what I'm here to say is that that is going to be built on what was basically ushering in all of the other revolutions: usability and standardization. But it's not just about making it easy for the end users to do this. What we've created is about making it easy for developers as well. So our end user-facing productivity apps, those are built on top of our Forge OS platform. It's really a common set of APIs that enable developers to hook up their products, their new technologies, and hook them up in such a way that it can now scale across the entire robotics industry, something that was not possible before. Before Forge OS, what you had to do is you had to sit there and you had to write interfaces for every single robot brand, and there are dozens of them out there. It takes a lot of time. Imagine, as a software developer, if you had to sit there and every single PC OEM was running their own operating system. It would be incredibly challenging to scale things effectively. So using this common set of APIs, we now enable developers to deploy their tools and their solutions in an easy way, in a usable way for end users to be able to effectively use. In some instances, this means working with one of our partners like NVIDIA, where in the NVIDIA Omniverse, you can now program simulations of industrial robots using Forge OS and these productivity apps, and then take those programs that you've written in simulation and seamlessly deploy them out into the real world to run on those type of robots without having to change a single thing. But it's not just about pushing stuff from computers out into the real world. It's about being able to easily capture data from the real world and bring that back into the digital world. And this is where we're going to talk a little bit about the importance of machine learning and the importance of edge ML. Because here's the thing. A lot of these factories, they're not in urban centers with easy access to fat broadband pipes. They're in far-flung parts of the country, far-flung parts of the world where they don't have high-speed internet connections, which means they can't do ML up in the cloud. They need the ability to do this locally on the edge in an easy way so that they can focus on what they're good at, which is solving complicated problems in a manufacturing environment, oftentimes with mechanical solutions, but oftentimes in ways that need to be able to leverage software and ML. And so together with Edge Impulse, that's what we've created. There's a demo, I think, that was seen earlier today. We got a robot out there today that actually shows this type of anomaly detection and how easy it is to set up. It's actually out there running on a UR cobot. But what's nice about it is because it's running on top of Forge OS, you can take that same solution and deploy it onto the hundreds of other robot models that we support without changing a single line of code. And this is incredibly important because while in manufacturing, we make a lot of stuff, I actually believe we don't make nearly enough stuff. In the OECD countries out there, there are over 400 million people involved in manufacturing today. And collectively, that's a workforce that produces a lot of goods, but so much goods that, frankly, less than 1% of the world can live the way that we do. So imagine for a moment if we wanted to raise the standard of living for 20% of the world. So 20% of the world could live the way that we do. To do that the way that we do it today would mean that you would need to involve every single human being on the planet in manufacturing. If you wanted to raise the standard of living up so that 100% of the world enjoyed it, it would be impossible doing the way it is today. So this is why it's so critically important that we have a standardized platform and easy-to-use tools that empower manufacturing experts to solve the complicated problems that they face on a daily basis. And the robotics industry is poised for massive growth. As I said earlier, there are about 400,000 robots sold per year. But if you look at the adoption curve for PCs, that places the robotics industry roughly in the early 1980s, which means that there is tremendous opportunity for growth. But there are complicated problems that need to be solved by end users, by manufacturing experts, by developers. And this is why I am a firm believer, a deep believer, that to really solve these type of complicated problems takes a village. It takes a village coming together. You know, READY has a part of the solution. Edge Impulse has a part of the solution. Bailiff, one of our partners, has part of the solution. And really coming together, we can provide the tools to the manufacturing experts out there so that they're able to leverage machine learning and robotics and automation and all sorts of other solutions to solve the extremely complicated problems that they wrestle with every single day. And by coming together like that, coming together like a village, we can usher in the fourth industrial revolution. We can usher in a new era of intelligent robotics powered by ML that can raise the standard of living for everyone out there, that can usher in a new era where humans are less at risk in manufacturing environments, where supply chains are more resilient because you can more effectively make things locally, where we can raise the standard of living for everyone out there. So I'm standing up on the stage today to say, please, come join us, and together, let's make the world a better place. Thank you.